Okay, let's see if this works. Can everyone hear us? I think we have a good connection.
Hello, hello.
Well, at least Marko and I can hear you. So
That's the most important part. We'll make sure the rest works as well. So I think what is in order is a little clap. Thank you everyone for joining. Thank you community. Thank you Memgraph team. So we have prepared for you another launch today, and we're going to show you the new things that happened in the Memgraph lab and how you can run Memgraph without basically any setup with like one simple click, and that's it. So let's dive into what's new. So I will select my presentation first so you can see my presentation. Welcome, everybody. Today, to showcase you all of these things, we have Toni, who is our head of cloud. He is leading the team that built all of these amazing things. We have, as usual, Marko, our CTO and our resident streamer in the house, who needs to resume his Saturday live streams. And we have me. We have me, your other favorite co-founder, who is the acting chief or cheese-eating official, as I like to call it, because I like cheese. Let's dive in. So today we'll cover a little bit about graphs and Memgraph in general, about how everything fits into the entire story, and where does the cloud come in and the Memgraph lab, and also we will show you a demo that we've built that you actually can play with yourself later after the show. Yeah, let's dive in. As I mentioned, the first thing to do is to give the big shout out to you, our community. Without you, none of these things would be possible. And also a big thank you to the Memgraph team and to all of the supporters of Memgraph so far, with our investors and our customers, our partners, and everyone who has been a part of Memgraph over the past couple of years. Another applause, I think. There we go. So, as you all know, so Memgraph is a graph computation platform for streaming data. So we've built Memgraph specifically for being good at this workload. And our purpose here is to change the way the world solves problems through the power of graphs. And why graphs? Because graphs can be all sorts of shapes and sizes. So they can model all of the processes in the world. They can essentially map out the entire knowledge very easily. It's what you write on the whiteboard when you're writing basically anything, any model, disassembling any problem. And it's what enables people to, when you're modeling the problem, you can approach to solving the problem. So that's how we have come here with all of these amazing things we have in the logistics department. Graphs are routing the entire internet. We wouldn't have Google Maps without graphs. So a big shout out to graphs as well. And the real problems we're solving with Memgraph are in various use cases. So what we enable people to do is run graph algorithms very efficiently. If you run graph algorithms at a certain scale, at a certain speed, you can gain really good insights. You can gain more insights from your data, which enables the timely and better decision making. And every leader, I think, would agree that timely and better decision making is crucial to the success of their organization. So these are the various use cases that we have uncovered. It had a lot of success so far, and I'm actually looking forward to kind of seeing what the community is going to build with this new release and with the new Memgraph Cloud, and yeah, see how all of that is gonna manifest itself. So since our last big launch, there are some things that happened that I want to give you an update about. So we actually released Memgraph MAGE, which stands for the Memgraph Advanced Graph Extensions, essentially very powerful and very fast implementations of algorithms, graph algorithms, both in the batch processing mode as well as iterative computation, which suits really well with the real-time processing on streaming data. And also we released GQLAlchemy, which is our Python object graph mapping library, OGM, which further simplifies how you can build your applications with the graphs by abstracting a lot of the heavy lifting that you have to do when building your when building your applications. And we actually had really good growth in our Discord community. Thank you, all Discord members, for being a constant source of new ideas, as well as giving the feedback on the product and helping us build the most amazing graph platform ever, as well as our GitHub Stargazers, something that I am pretty happy with. We had really good growth in terms of the GitHub stars. And if you're watching this and you didn't give us a GitHub star yet and you like Memgraph, you should certainly head out to GitHub and give us a star. I think every Memgrapher's heart shines when a new star is added. So please give us some stars. I see we have a bunch of people also here in the live stream. Hey, everyone. All the way from San Diego as well. And yeah, some familiar faces as well. Thank you for joining. Let's see what we have next. So we have our puzzle. I'm having to switch my program and my light just went off, which is not a good sign. Hopefully the live stream keeps on. So we have multiple pieces to the Memgraph puzzle. On the left-hand side, you can see that everything starts with data ingestion. So you need to get the data that you already have somewhere. That can be historical data, can be in CSV, MySQL formats, and various different formats, as well as data streams. So we support Apache Kafka, Red Panda, Apache Pulsar, and you can get all of your data sources in and really kind of choose what kind of information you want to build inside the graph, inside the model of the problem that you're solving. And then what happens after ingesting that data is that you can actually supercharge the insights that you're getting from the data from all of the graph algorithms that are in the MAGE, or you can build your own through our query module API. And also, if you feel like it, you can also contribute to our MAGE library if you have some sort of a special algorithm that you want to share with the community. My screen froze. There we go.
It seems to be working. Just
you see it, but I don't.
Yeah.
That's good. So then you can run all of these things, all of the algorithms on Memgraph. You can gain its insights into the data, as I mentioned, and you can use those insights to build all different sorts of apps on top of that. And those apps can provide much better decision making, be it like a fraud detection system or like an optimization system or anything in between, impact analysis, root cause analysis. And you can essentially build your own red team in-house who can gain all of these insights from Memgraph. And why should you care? And why is this different? Developers will be able to do it in the cloud and within a browser. So far you had to download Memgraph, you had to deal with Docker and all sorts of shenanigans to get Memgraph working. And we've worked pretty hard to automate all of that processes with you. So you'll be able to ingest the data streams, you'll be able to run graph algorithms, and you have a smooth developer experience with Memgraph Lab, which is our integrated graph environment. And there are also a lot of improvements on the lab that you can take advantage of. So without further ado, I think what we'll show you is the book recommendation engine from the Amazon Books dataset. One slide too far. And I'll give the word back to Toni, who's going to tell us more about the Memgraph Cloud and give us a demo.
Hello, everyone. As Dominik said, I will walk you through all the changes regarding the Memgraph ecosystem and especially the cloud, so you can run everything within your browser. And we will move towards the lab. So I will show you how you can set up a stream, run a simple recommendation engine on an algorithm that we will present to you. And then we will play around in the lab so you can see all the new ticks and tips that we added, all the new features that we think you will find useful. So
awesome.
Yeah,
let's dive into it.
Let's dive in. Yeah. Wow, what an audience!
I'm here I'm here just to wave.
Yeah. Well, someone needs to do that. So thanks for jumping in. Okay,
Marko is a resident cheerleader.
Let's get in. So first of all, let's register to our lab. I will log in with my Google account. That's the easiest way to get into. First, the classical terms of service. So yeah, let's take a few moments and we will read through the actual terms of service. So let's start. Please review and accept. Okay, come on, I'm kidding. We won't spend the full call reading the terms of service. But
so
feel free to...
Almost.
So essentially, this is where you sign off your kidney to us.
Yeah, but only one, so don't.
Only one, yeah. You still get to keep the other one.
No, but jokes aside, feel free to read it. You also have terms of service on memgraph.com, so you can always go back, read it, and see what's in there. So I agree. I have 2 kidneys, so. So what's your preferred language? So if you're curious why we are asking you this, it's more around what kind of recommendations, guides, and everything we can send to you. So we will really create a tailored newsletters, algorithms, depending on the language you selected. So it will help us and it will help you as well. So you won't receive all the fuss around the other languages. So let's go in. Okay, yeah, create new project immediately. Let me just click X here. So I want to show you, like, this is a simple login screen. On your first sign up, you will receive a 14-day free trial. Feel free to use it, run your free trial project. No card needed, so just run it. I will do that right now to show you. So what we did, we pre-filled the free trial settings. So what we have also, you can see the 16 gigabytes of RAM instance will cost this much on a monthly basis, 8 gigabytes and so on. So I will show you later on. We have different prices depending on how much RAM your instance uses. We'll go with the free trial one for the sake of demoing, and let's call our project Amazon Book Recommendation. These are the regions where you can run your instances. Our plan is to add more in the future. So you have 3 US locations and 2 Asia Pacific and 1 Europe, of course. So let's go with the Europe. It's the closest one we have here, and we will save some bits in terms of latency. Cool, let's go next. Okay, so this is a really crucial step. So what are we asking you here is you need to define an admin password for your Memgraph. It's not the cloud account, it's the Memgraph that you are starting out. So why is this really important? Because once you start your Memgraph, we don't know the password you typed in here. If you lost it, we cannot help you. So we don't have the ability to connect to the Memgraph that you are running. So this is really important step. It would be really funny if I forget what the password is. So luckily we have a copy here, so you can really copy and make sure you have the admin password with you. Okay, let's go to the project. So project is starting. So while we wait for it, it will take few. Okay, it's already running. I thought it would be a bit slower, so I can go through the cloud application. But let's dive in.
On live demo, everything works always.
Yeah. So let me show you a bit around the cloud.
Everything's gonna be good.
Yeah. On your account, you can see your account. You can see your free trial, how long it takes. If you need more days, feel free to reach out. We'll be happy to provide you more free trial days so you can try out Memgraph in browser. Coupons, credit cards. Regarding the credit card, you are safe because everything is with Stripe. We are not storing your credit card. We are not storing anything from terms of payments, card, and so on. So everything is on Stripe. You have the notifications, which is more as a history management. You can see all the actions that you did so far. Snapshots are here for you to create backups of your cloud Memgraph. It's great because you can save backups in different periods. And also it can help you when you want to boost up the RAM. For example, you're running a project with 2 gigabytes of RAM and you want to create a new one with 4 gigabytes, 8, and so on. Depends on your needs. Okay, enough of the walk through the actual application. These links can help you, the community, the documentation, and so on, but we will dig deeper into those into the next steps of the demo. So let's go back to the project. So this is my project, the Amazon book recommendation. What you can see here is the information that you actually use on a creation page, a region, how much RAM it has. You have all the different actions on it. You can pause it, you can resume the project. So what pause actually means, we will stop your Memgraph. When you resume it, we will start your Memgraph again. Delete, well, as it says, your project will be removed. So your Memgraph will be removed. And if you don't have a snapshot of your data will be lost as well.
Toni, when the project, one question, when the project is on pause, do you get charged or not?
So well, this is a free trial project now, but if you are running a paying project, when you are, so currently these 3 items are the metrics that we charge you for. Let's say if I were running 8 gigabytes of RAM and I have 2 gigabytes of network and I will have different disk usage. So we will charge you all 3 parameters on monthly basis. And if you pause your project, well, your Memgraph is not running. So in that period of time, when the project is paused, we will only charge you the disk usage, which is almost 4 or 5 times less than the actual price. If you are curious about the prices, you can always go to account and see how much it will cost. And you can select the region. Let's select Ohio. You can select how much RAM, and you can see our monthly estimate. And these are the RAM cost, the storage cost, and the network cost. So you can calculate depending on how much you would use. And you can change different regions and see, well, Hong Kong is probably the most expensive one as far as I can see. So yeah, you can really go through and see all the pricing ranges and how much it could take.
Maybe to explain which cloud provider is used and why the prices are different.
So currently, we are using the AWS as our cloud provider. We have a plan to include the Google Cloud Engine and Azure in the future. And why the prices are different? Because the baseline is the AWS prices. So that's where on top of it, we add the license, the enterprise memgraph, the support and everything along with it. And that's why the prices are different depending on a region, because that's also how AWS does it. It depends how much, what's the cost of their data
What's the actual cost of running a dataset there in that location?
Exactly, exactly. So I don't know what will happen with the upcoming inflation. It's not upcoming, it's already in progress, but our prices currently stays the same. So no worries around it. Okay, let's go to the project. This is my project. And we always like to help users how to connect, how to start, how to see what's going on. And here you have different ways to connect your memgraph. For all those guys that like black terminal screens and nothing else, like black is my color, you have the MG console, which is our terminal application. With this snippet, you can actually connect to this remote memgraph and start querying, see what's in there and so on. For all the developers out there, we have the connect via driver. So these, as you can remember, are all the languages from the onboarding step. And we will present you the installation step and the actual code, which you can copy, start. And this is a great way to actually start with the in-browser memgraph. As you can see, we are using the GQLAlchemy, when Dominik said a few words around it in the beginning of the video. Buddha, maybe, Marko, can you maybe tell a few words about the GQLAlchemy and all the efforts that have been done there?
Yes, sure. So GQLAlchemy is a nice Python library to interact with memgraph. Basically, the idea is to make the interaction with memgraph as easiest as possible for Python developer in particular. Essentially, you don't have to learn Cypher, or you don't have to learn. The intention is to learn as few details as possible about memgraph and still being able to interact with memgraph. So basically, we put a nice interface around the whole memgraph, and you can do essentially everything. So it's not only about memgraph, it's also any Cypher compatible and Bolt compatible database or system can actually be queried through the GQLAlchemy. So it's actually a very nice way of abstracting the database from your application. It's a very nice isolation, so you don't have to build your own abstractions for the graph. Basically, that's the idea. And then the team put a lot of effort into open sourcing the whole project and like contributing towards that. So yeah, hopefully we can get some good feedback and improve upon that. So yeah, please feel free to pull, fork, do whatever, and happy to help on that side.
Yeah, thanks, Buddha. And as I said, you can switch the other languages as well. Use that as a baseline for your connection to memgraph. But for this demo, we will show you the connect via client. We all like visuals, so let's get in. So here you have two different ways. You can either connect in browser, and we will be using memgraph lab in browser experience. The other way is you can download the application and run it from your local desktop application. You can connect to your local memgraph, to the remote memgraph, wherever you want. So it's a client, visual client that will help you with your graph experience using memgraph. So let's connect in browser and see what we have there. As you can see, all my credentials are pre-filled except the password. We don't, as I want to remind, we don't know your admin password. So it would be great if I input the wrong password. But luckily, everything works okay. And I'm now connected. Yeah.
One more applause because it's working again.
Yeah. Yeah, imagine how many people forget the password. So, and yeah, we don't have forget password for Memgraph Cloud because, well, the instance itself, because as I said, we don't store your Memgraph password anywhere. So this is the memgraph we are connected to. You can see the IP, you see 18. That's the actual memgraph that we are connected to. So this is the new lab. I'm not sure how many of you have been able to install it. So it's version 2.00. We also have a lot of new fixes and new improvements in there. So feel free to download the new version or use the in-browser one. So in the app, you have the status bar. It's the most relevant.
Could you zoom one level up?
Of course. Yeah. Is this okay? One more?
Yeah, sounds. Yeah, I think that's perfect. Yeah.
Okay, cool. So yeah, you can now.
For us, the blind ones with the glasses.
Yeah, you can store your glasses to your drawer now. Okay, so we have in the status bar, you have all the relevant information about the number of nodes, number of relationships, disk, and the actual memory, what's used and how much, what's the total available memory. You might see, okay, but yeah, we started 2 GB RAM Memgraph instance. Let me show you why then we have only 1.54. It's actually because the operating system and all the other services are using the rest of the available memory. So this is the Memgraph. In the welcome screen, we are trying to guide you with one simple queries, how to start your journey with graphs. We have a lot of documentation to help you with. But for this case, as our demo says, we will focus on the Amazon book recommendations. So we want to start with the stream. So let's connect to a source.
But Tony, where do we get the data?
Oh my God, yeah, that's true. Luckily, there is an awesome people from Memgraph, and they provided the awesome data stream. So this is the site where you can see all the publicly available streams, Kafka streams that you can connect to and practice, test, run, create recommendation systems, and so on. If you don't have a working stream in your environments. So yeah, maybe I know. Don,
awesome
can
data
you say a few?
Stream. Yeah, so it's Memgraph's DevRel team actually built this resource for all the people who are learning how to deal with streams. You can use the streams for whatever, but they're particularly suited to use with Memgraph. And as you kind of go to one of those streams, as the Amazon stream, you can get all of the connection details and kind of how to connect it, how to transform it, how to import the stream into Memgraph. It's just a series of steps and off you go. You can use it both with your local deployment of Memgraph if you're testing Memgraph on the computer, or you can use it with the Memgraph Cloud, which essentially gives you a total of like 5 clicks, and you start a Memgraph instance and you get the stream running. It's a little bit more than that, but you can definitely get started in under 5 minutes.
Yeah, true. Let's hope it's less than 5 clicks now when you said. Okay, let's add a new stream. Well, we know that it's a Kafka stream, and we also support Redpanda along with Pulsar as our stream sources. Let's call our stream Amazon Books. Okay, so we need a server address and topics that we will subscribe to. And thanks to awesome streams, can I hear an applause? Thank you. Yeah. Let's dive in. So this is the server address that we will use. Let's copy paste it here. Let's go on. What's the topic? Book ratings. Awesome. Book ratings. Let's go on. So currently the stream is not yet created. It's in draft mode. Why is it in draft mode? Because there are some other steps, those 4 clicks that Dominik said, where we need to finish our stream. And in this image here, you can actually see what we are missing, and that's the transformation module. So why do we need a transformation module, you might ask? Well, the stream that's coming in, that will be coming into Memgraph soon enough, is linear. So we have the books and users ratings, but Memgraph doesn't know how to transform that linear data into a graph representation. So that's where the transformation module comes in. The transformation module is really simple to define. It's Python code. You can also create it in others, but we will start with Python because it's the easiest way to get around. Let me just, you can also edit the batch interval size. I won't go through every single settings now because you have a really good documentation around it. You can read it out and see what fits you. But I will just change the consumer group because I will make some new consumer group because I want to start from the beginning of the stream. My new Amazon group. Okay, so let's add the transformation module. So currently you can choose if you already have few, but we will start with a new one. You need to create a name for it. Let's call it Amazon Book Transform. Let's create it. And what we will also show you is the in-browser code experience. So this is the sample transformation that will work for any kind of stream. So it's the really regular one where we, for every message that comes in, we will create a new node with a timestamp, where it comes from, with a payload, and so on. So with the example transformation, we also are giving you guides that you can check, the documentation on how to write the transformation, and the actual explanation of all of it. Don't worry, you can always hover on all the MGP things. So MGP stands for Memgraph procedures or Memgraph processes. And you can get the full documentation in browser, in the editor. You can see what it has, what it contains, what you can do with it. For example, in this particular instance, we will use a different one. I will show you, but let me just walk you through the transformation just so you can feel how simple it is to start it. So in general, the transformation code receives a batch of messages from the stream source. And what we want to return is Cypher queries that we want to run on every batch of messages that we receive. In this particular case, what we are doing is we are iterating through the batch of messages, and for every single message, we will create a Cypher command, which is let's create a node. And whenever we save this, so when we start a stream, every new message that comes in will actually create this node over here. So that's a way how we tell Memgraph, hey, this is the way how we want to transform the linear streaming data to a graph representation. Okay, so you can check the sample.
Expand a bit on this. I mean, you said all the right stuff, but also like the way how you transform messages into graph is not straightforward. And basically, this is the most powerful way you can actually do that. So you can create vertices, edges, or anything you would like. You have full flexibility of defining the transformation function. This is possible to write in like Python, C++, Rust, eventually we'll add more and more default transformations. So, for example, by default, you can create you can transform any message to a vertex or to an edge, or there are like feasible default options. But yeah, that's going to be part probably of MAGE or GQLAlchemy in the future. Yeah, sorry for interrupting.
Thanks. No, thanks, Mark. Thanks for jumping in. So thanks to awesome streams, applause. Where is applause? Yeah, okay.
A little bit of a delay when I press the button.
Yeah. The audience is probably shocked with the transformation module. Thanks to the awesome streams, you have the transformation for every single stream that
it's a properly documented code. So you have half of the code, half of the documentation. So it should be fine.
True. And also the schema as well. So let's move on. So this is a transformation that we will be using. I will now walk you through the actual transformation. So what the transformation does, you can see it's actually pretty much the same. It receives a batch of messages, and we need to return Cypher queries. And same stuff you've seen few minutes ago. We are iterating through the batch of messages, getting the actual payload of it. And what we want to do, we want to create a unique book by the ID and the title. We want to create a unique user with the user ID, and then create a rating between those two. So this is what Marko was saying. Actually, recently around it, you can create how, like, you can see we are creating two nodes and a relationship here, or maybe just a relationship if we already have two nodes in there. So this is our transformation module. Let's save it. Cool. And let's also attach to our stream. So now we have the transformation attached. You can always edit, see what's in there later on. Let's add few Kafka parameters. Why do we need that? Because you can see we need to input the additional Kafka parameters in there. So let's get to. So the first one is the username. Okay, and it's the public one. We need to have a password. It's also the public one, if I can remember correctly. The next one is the security protocol. Okay, let's add that one. So we have the security protocol. And the last one is the mechanism, and it's plain. Okay, cool. Let's save it. The configurations are in there. And you're ready to go to connect your stream to Memgraph. So what it says now is, are you sure? Because once you create a stream, you cannot edit it anymore. The only stuff that you can edit is the actual transformation. So the server address, the batch size, everything is within your Memgraph. So make sure that you are ready to go. Don't worry, even if you misspell something, you can always delete the stream and create a new one. So yes, we are ready to connect our stream. So our stream is connected, and what Memgraph is doing now is running a test transformation. So Memgraph is fetching at least few messages just to run your transformation, so you can, well, not easily, but you can see how what your query looks like and what the parameters are in. But yeah, no worries. This is coming, like the new tables, new results are coming in the new lab version in few days. So you will be able to expand this and see the actual result that you received from the stream. But our stream is not yet started. We connected it and it's tested. Let's now start it. Okay, so the stream is started. You can immediately see we are starting to receive a lot of new nodes, new relationships coming in real time. So we are updating this every few seconds, just not to press Memgraph with the metrics and all around it. So now we have a stream working on. Well, what would you probably do when you have a new data coming in? You want to see what's inside. Thanks to that, we have a graph schema in the sidebar, and let's check it out. Woo, this is our graph that's being created from a stream. What it does, so we have a user, which is a node, and a book, and edge rated. If you click on it, you can see all the properties in there. So we have an ID, which is present in all the nodes. We also have the book node. We have the ID and title. I know, what do you think, like, why do we have this 100% present and so on? Well, I'm not sure how much you wrote Cypher queries, but you know that sometimes the property that you are searching for or using in your analytics is null and it's not in the node. And this is super helpful because you can easily see if the field, or if the property is present in all the nodes or not. And we have the rated, which has the rating and the timestamp. So graph schema is really cool way to have a summarized version of your graph. Okay, now when we have the schema, when we have the stream working on, let's move on and let's run some query. So the best query to start with, especially if you want to see what's going on in the database, don't run this if you have hundreds of millions of data, because a black hole will probably be created somewhere. So, but we have 300 nodes, it's not too much. And you can see, this is, let me just hide the editor so we can focus on the visual. As you can see, these are the users rated a book. If we click on it, we can see an ID and a book, the title. Oh, architecture to construction. Oh, sounds interesting. But only one user currently rated it, so I'm not sure how interesting it is. Let's see a book that has a lot more ratings. Okay, this one. Oh, a merciful silence. Okay, let's find another one. But as you can see, this is a graph where we can see how people are rating the books and what's going on. We currently don't have a live update, but if you want to rerun it, just rerun the query and we will get the latest state from our streams. What's cool is the actual graph view can help you a lot, especially if you want to style the graph. For example, a really cool way, especially if you have just these colors, what we can do is we can style books, we can style users, but I will get to that a bit later. Let's get to the algorithm. I'm sure a lot of you were saying, okay, Toni, like we've been talking for 50 minutes and there is no A of algorithm, like what the hell? Let's get into it. A cool way actually to, sorry?
Let's get some insights.
Yeah, a cool way that I'm sure you heard of MAGE. MAGE is, well, it's a wizard, but also MAGE. MAGE is something else in Memgraph world. Marko, can you give us a brief intro to what MAGE is and what's the purpose of MAGE?
So as Dominik mentioned, so these are MAGE stands for Memgraph Advanced Graph Extensions, and idea there is to build off-the-shelf implementations of the algorithms in all supported programming languages. Since Memgraph has these the interface like, let's say, first-class interface in C, it's possible to build all these algorithms in almost any programming language. Memgraph can load that and then run the algorithms. And then MAGE has a whole range of available algorithms which you can run. And it's also not only about, let's say, static or simple algorithms. It's all the different combinations. So, for example, you can run static algorithms or, let's say, regular graph algorithms. Then we also have the dynamic ones that work the best on the streaming data. And also we do integrations with other libraries and systems that are running graph algorithms. For example, NVIDIA has a cuGraph library, which is very nice to accelerate some of the graph computations on the GPU if you have a GPU available on the server and the algorithm. And once you have data in Memgraph, which should be super easy, or at least we are trying really hard to make that very easy, then you can offload stuff to GPU. So essentially, MAGE has a bunch of off-the-shelf capabilities that you can reuse.
So essentially, MAGE gives Memgraph superpowers.
Exactly.
Yeah.
And that's
the story.
Yeah, and we will get to the one of those superpowers. So if you go in there, or if you run Memgraph with MAGE locally, you can see all the latest algorithms that can help you out. And the one that we are interested in is the PageRank. Well, where are you? Oh, here are you. PageRank. You can check in. You can see what functions does it have. and currently has the PageRank.get. What's cool is you can always get to the actual documentation of the PageRank and read about it, see how it works, why it works like that, even have an example online. But within the lab, what's also cool is that I will now show you something that we've been calling lab as an IGE platform. So I'm sure a lot of you are familiar with the IDE, which is Interactive Developer Experience. And we were thinking, well, we love developers. Developers like to use Memgraph. Like, let's just combine everything. And what do you have from the Fusion? Welcome layouts. So what's helpful is you can have one layout of the query module. You can have one layout of the query module, and on the another one, you can have a query execution. So you can read what's going on and as well as run different queries. Usually what people like to do is open a horizontal layout and have logs in there. And you can see in the logs, our stream is working hard. Like every few seconds, new batch of messages comes in, so we can actually see what's going on. What's cool, even if our logs got disconnected, it will connect to your Memgraph, so no worries there. I will just close the logs now. We want to focus on the execution of the PageRank. So I'm sure if you are not familiar with the PageRank, it's the well-known algorithm that Google actually started with their search engine. What it does is it checks different how things are interconnected, and the another name for it is impact analysis, how many things are connected in between, and if some node is really important, then the node that it's pointing to will be even more important, and so on. And with this snippet here, what we want to do, we are calling the PageRank.get, which is here. And the new lab will give you the same code suggestions. So you don't need to remember all the ways how the algorithms are called. Don't worry, so we got your back. You will have all the parameters in here, so you can easily write it down. Even if you don't have it, like I can show you, if you start writing it down, we'll help you out immediately to show you all the modules that you have there and all the functions that you can use, as well as the properties. So if you start, we will show you what property you are currently on to really ease up the usage of the query modules in the lab. So let's get back to calling out. So what we are doing here, we are calling the PageRank algorithm on the whole graph. And we want to see nodes and their rank, which is a number. And we are only focused on the books. So that's why we have this where node book. And we want to see the title of the book as well as the rank. And we will order them by the rank. And let's see what we get. And you can see this is probably the most popular book so far. So Beneath a Scarlet Sky. And then comes the merciful silence. I'm sure you remember that one when we were going through the visual. So these are the books where, so the PageRank algorithm ran through the whole graph. We got the books and their ranks. Like, isn't this cool? Like, I think we are not 5 clicks, but maybe 7 clicks. And you have a PageRank on the streaming data of the Amazon book recommendations. Applause. Yeah. So
that's something special, definitely.
Yeah, yeah. But okay, so you might be thinking, yeah, this is cool, but where are the recommendations? Yeah, okay, let's get into it. So we'll probably need to have a
Hold your horses, they're coming.
Yeah, for a user. So what we want to see user rated a book. This is regular Cypher. I'm sure a lot of you are aware of. If you are not, check our docs. It's a great resource to start with. And this is actually a query where we want to return the users and a number of books each user actually read or rated in this case, and we will return the top 3 of them. So we have few IDs here for sake of sensitive information. That's why you don't have the people names and all that in there. We have just the ID, but that's enough for us. Now let's see what kind of book we could recommend to this user I just copied. And this is the ID I copied over here. So what we want to do is we want to match that user. We want to collect all the books that user already rated. Like, we would be a really poor recommendation if you read A Merciful Silence and then we would recommend you A Merciful Silence once again. Like, let's at least step up a bit. So what we want to collect all the books this particular user has already read. We will run the PageRank, and then we will get the books and filter the ones that user haven't seen so far. And if we run this, voila. Well, A Merciful Silence. Well, I'm sure this user haven't read A Merciful Silence. And as you can see, this book is the first one to recommend to this user. And so far in this example, we are not using the scores of the rating or checking the genre of the books. This is, let's call it a popularity recommendation engine. So we will recommend you a popular books, but we never said what popular means. That's what PageRank is for. So that's a cool idea, where the actual logic of what's popular, it's already in the algorithm itself. So you don't need to worry about counting and all that kind of stuff. Okay, so we could recommend Merciful Silence to this user. Let's call it Alice. But there is a trick. Like, we have a streaming data, and you can see it's still coming in. And this is a static library, like a static algorithm. So we just run it, we get the results and so on. Like, okay, but that's not the point of it. We wanna have PageRank running on every single new data that's in there. Why is that so? Like, imagine that we are running this stream for a few months and we have a few millions of nodes, few millions of relationships. And if you run a PageRank, it could take some time to calculate the impact analysis of the full graph. And even though this is a fine solution, it's not really what we want. We want to utilize something that we are calling the dynamic algorithms. Marko, okay, let's hear a bit about dynamic algorithms.
So with idea with dynamic algorithms is that why run very expensive algorithms on top of the whole data set, while you can take that premise or let's say hypothesis that data is coming in as a stream, and then basically you can just rerun a small portion of the whole compute you have to actually run on the incoming data and maybe nearby data which is touched by like creating edges or something. And usually these dynamic, that's like a huge research field at the moment. Not all algorithms are possible to be implemented as a dynamic algorithms, but a lot of them are actually possible to write in that way. Basically, a bunch of these algorithms are based on random walks, and like these are actually well-known techniques from the machine learning and data science. But yeah, based on random walks, you can actually get the exact results or good enough approximations of the results, because also with analytics, you usually don't need very precise number. You just need a good like comparison between these results. So here we are actually exposing very fast, very efficient algorithms that give approximate results, which are usually good enough.
Yeah.
This went a bit technical, but essentially that's the idea.
That's cool. That's cool. Okay, so let's,
Awesome.
with that great intro to dynamic algorithms, let's get back to the demo. So don't worry, we got your back. If you want to run anything that's dynamic, it's suffixed with the online. So let's get into the PageRank online. And you can see there are several procedures that you can use. Each one have different properties and so on. But that's where we want to check the documentation. Well, as you can see, the documentation for the online is a bit larger than the one before, but no worries. Like, what's really cool is you have a full description of how to use the dynamic. And I will save some time, but what it says here, it says use set procedure that will set the initial state, and make sure to create a trigger that will call the PageRank online update command with the new created vertices, edges, deleted, and so on. So what this actually does, so we have the initial state, we will call it just now, and then we will create a trigger for all the new data that's coming in from our stream. And then we have a PageRank, dynamic PageRank running with the initial state and all the new stuff that's coming in. So what does that actually mean? That means that we will have this rank property on every node that we can use. And the PageRank algorithm will update that property on every new change. I'm feeling the excitement from the audience. So let's move on. Let's check how we can do that. So first steps. Let's first run the actual, well, let's just limit 10 of those. Let's set, so this is the set that's setting up the initial state. Let's run this query, and we'll only return like 10 nodes, and then we'll see what you can see in the data results. These are the initial ranks for these particular users and books. Okay, we have the first step, and if we remember the documentation, they said, yeah, please add a trigger if you are working on a streaming data, or you want to, not just the streaming data, but you want to create a trigger for every new node that's been created or deleted, and it works for edges too. So with this, we actually created a trigger, and now the PageRank is in place. It's dynamic, it's listening for changes, and it's updating the actual rank of all the nodes. Okay, well, okay, Toni, but how can we test that? No worries. Let's see what's going on. Let's run a query. Let's show a few books. So this is a really simple one. Match books where rank is set, because we might miss that few while creating a trigger. Let's also create, let's return a title rank and sort them by the rank. Okay, here we are. These are the books and these are the ranks. And if I run this a few times, I don't know if you can see, but the ranks are being updated. And that's what the PageRank dynamic is doing. Like, it's updating the ranks. So you don't need to run PageRank anymore, but you can just, like, yeah, thanks to Memgraph, buy a beer to Memgraph. It's running PageRank for you. Okay, cool. That seems
under the hood, no one notices, but you have the new results.
Yeah.
Frequently. Maybe if you, since the whole dynamic algorithms are quite new initiative, please put in the comments or somewhere on GitHub what would be nice algorithms to actually implement in that way. We have a few, plan to add much more, but it would be helpful to get like insights about what would be the most helpful ones that we can add.
Okay, let's see the graph schema. Let's see, and you can see the rank is in there. Like the page rank is actually adding ranks to users, to books, and we can see it's 99% present, so we can cover those that haven't come in, but no worries for now. Okay, so we have all in there. let's play something. Before getting back to the actual recommendation, which is the last step of the recommendation engine, let's show all the nodes and all the edges. Okay, there are a bunch of those, and it will take some time, but really some small amount of time to show them all. And what I want to show you is like these are all.
You actually know exactly. You actually know exactly how long it takes. How long you have to make a coffee.
Yeah. Okay, so we have, well, it's a really huge graph. Well, not that huge, but I want to show you some cool trick with the GSS. So that's a Drive style script. It's like a similar CSS language with which you can actually style the graph that you are seeing here. It's great if you want to show the visuals of your graph. And what I want to show you is we have a book over here, and we want to show that, for example, a size of a book node. Let's say, let's get the property of this. Oh no, it's not the edge, it's node. And let's pick the rank. Okay, this might be null. So because we have few books that are not defined, so I will just copy this. And I will remove the colors. And what I will do here, if my node is book and has property my node rank, we will run this style. Okay, so what are we going to do here? We'll say that our size is, let's get the property of a node. I'm not sure if you have seen, but we are actually helping you with the GSS, so you will always have a support of code suggestions, the context information, so you can know what it receives, what's the expected output, and so on. So it can be easier for you to write the GSS. So we'll take the rank of this book. Let's see. And you can see, wow, where are the books? Oh, what's going on with the book? Yeah, no worries. So the problem is that the ranks are 0.004 something. So what we are going to do, we will multiply this by, let's say, 100. Okay, we have something going on here, but not too much. Let's add one more zero. Woo! And now, visually, you can actually see what are the most impactful books in there with the actual graph style script. What's cool is like if you hover, you can actually see how to use all of this. Yeah, Marko.
Yeah, as you can see here, like the GSS is a full-blown language, so you can do arbitrary code here and basically go full retard with the styling and figure out nice visualizations for the graphs.
Yeah. But let's get even crazier. I mean, the most favorite one for most of our users is actually adding a few images. So let's search for some book icons. Okay, black one. This, and it's also circular. This looks like a Memgraph colors. Let's pick this one. Okay, please make sure to align with the copyrights and all of that, but for the sake of presentation, we will add the image for these books. And let's say, so the image URL, that's the property. And if we add this, now we have, you can see, well, you can see the images. Well, this one is really huge. You can see the actual image that we added to all the books in our visuals. It's that simple.
That's very nice.
Feel free to send us like some crazy visuals that you created with the GSS. I will show you in a few minutes now what other crazy stuff you can do with it. But let's get serious now. Let's get back to the algorithm. So we have the PageRank, dynamic PageRank running out. And if you remember, this was our, where are you? The book, that's the book, this is, oh, here it is. This was the query where we were running the static page rank. So let's get the user, let's run the page rank, and let's see what books should we recommend to that user. But check this out now. Like I will keep this vertical here so you can see what's the previous query. Let's create a new one. Oh, I need this ID. Oh, it's already the same one. So we want to match the user. We want to collect the books that user already rated. Let's get all the books. Let's check the rank and just give you the one with the highest rank. Like we are not calling page rank anymore here. It's in the background. It's dynamic. We just run this and voila, you have, well, now we have a new books. A merciful silence has dropped to the 6th place. It's choose your own disaster. What kind of books are these?
These are like, the new recession books, I guess.
Yeah, lies that bind us and so on. Okay, well, these are some other books, but you can see how we moved from like creating a stream, checking what's in there, running a few test algorithms, creating a dynamics of it, and then just using it. This is really cool because now if you have few users using your Memgraph, they don't need to know about PageRank. They don't need to write it down. They just need to write a simple Cypher query or use other development tools like GQLAlchemy and so on, so on. Okay, let's stop our stream. This is our stream. You can see it's running. Let's just stop it. So we stop the ingestion of the data. Like now the new data won't come in anymore. You can always start it again and it will continue getting new data from the point it was stopped. So you won't lose any data in your Kafka stream. So we will stop our stream because I want to show you a bit new stuff around Memgraph Lab that we added, and I'm sure you will love it. Before getting into the few other features of Lab, Marko, Dom, do you want to add to anything to the streams and the algorithm part?
This was very nice.
I add a lot, so I'm good.
Yeah, like
I like all of the features of the new lab, and it's now like a complete product together with the cloud and with the data streams, and you can like in really like 5 clicks essentially create something awesome. And if you give a little bit more effort with the graph styling, you can also present the data very nice.
True. I'm seeing the audience. Yeah, the audience is. Yeah. Go on, Mark.
It has a bunch of cool features and it's really an IGE. So the idea is to have all these capabilities at one place and expose them in an easy way. So definitely there. And we're going to improve further. So yeah.
Yeah, definitely true. And thanks to all the feedback that you provided so far, it's really helpful. And please just keep sending those. And what's also like, and as I'm seeing the audience is still with us, so can we say some applause to them for continuing with our lab?
Applause to all of the 19 people who stayed.
Yeah. Okay, so we loaded Pandora Papers. It's just a subset of the offshore entities, and I'm sure you are aware of the Pandora Papers. I'm sure once it's digitalized, we will add the rest of it. So let's run a sample query. And you can see this is a sample query about Andrei Babis. I'm not sure if I'm pronouncing it correctly, but our Andrei had relations to Luxembourg, Czechia, Monaco, and so on. So yeah, he is part of the Pandora Papers. And what's cool is you can see how he's connected to other countries, to other entities, and so on.
Not to put him on the spot, though.
Yeah. Luckily, this is not live. Okay, so what's cool is if you ever have some interesting queries, you can always add them to your collection. And with the new collection, you can group the queries. It's really useful whenever you want to showcase to someone or you want to return to the previous queries. So let's call this queries Pandora Papers. And now our query is added there, and if I want to return to it, I don't need to search through the latest queries. I can go to the query collections. I have my Pandora Papers, and here is my query over here. I can run it, I can copy, I can send it, and so on. In the future, we will add import-export functionalities, so you will be able to share your query collections to other people. Okay, so let's get back to the, I want to show you something. Like in the datasets, what we added is now you don't just have the title and so on. You can go to the quick view and you have the model up ahead. You have the description, you can see what it has, how it looks like, and so on. So you know what you're actually importing. Like with the Pandora Papers, you can see this is the model over here, and you have all the examples and how the data is actually structured. So it's really helpful to know what your data looks like before you actually load it up. Let's just check the schema. This is the schema of the Pandora Papers. We have entities. These are the companies, and they are registered in some countries, and we have people, officers that are from some countries, that are related to some other countries, and they are somehow tied to the entity itself. And you can see now here how helpful it is to see how many properties are in each node, because it can be helpful for you when running some other queries. Okay, let's now move on and run a query. Okay, I don't need this one anymore. I want to run the most famous one, which is, this is a cool stuff. Like if your graph is small enough, small in terms of like few 100,000 nodes and few 100,000 relationships, will help you out in whenever you are writing a Cypher query, where we will show you all the node labels as well as node relationships. And so it's much easier for you to actually know what's in your data set as well as properties. It's not tied to the country. You have all the properties, but it's still something. It can be really helpful to do all of that. And it also works with the edges and the other entities. And what is cool is if you type n, which is our variable for a node, dot, you will get all the properties as well. So you can work with them without reading documentation and so on. So already in place, I think it's super useful whenever you are working on a new data set or a data set that you can't remember what was in there and so on. Okay, so let's return all the nodes, all the properties. Okay, this is our Pandora Papers. You can see a lot of them are registered in Virgin Islands, in British Virgin Islands. And okay, this is our graph. Let me just hide this a bit. So with the new graph, you can do the stuff that you could do before, which is hide the node that you clicked on. You could also, for example, this is Malta. We can also hide Malta. This is just the visual hiding. You're not removing nodes from your database. This is just regarding the visual, because it can be much easier to actually expand, collapse. Let's collapse everything to this node and expand later on, and then we will recalculate how we want to show your graph. So it's really just a helpful way to go through your graph. If you want some dynamics, and we are not talking about dynamic algorithms, you can enable physics over here. I'm not sure if you can see, but nodes have some action in there now. The things are moving along. And what's really cool, you can always open graph preferences and maybe spread them a bit or make them closer to each other, really close. And you can see they're too close. But really what we found really cool is the default works for most cases, but this is a cool way for you to manually define how you want to see your graph. Okay, let's disable physics. There is a lot of movement in there. And what I want to show you is I'll now get to the actual graph style script, because I want to show you some new stuff that we added, which is especially relevant whenever you have a huge graph and it's really hard to find what you're looking for. You can always filter out your Cypher, but there is a better way to do it. So let's get into it. This is a default graph style where we cover all the nodes, all the properties. And what we are going to do now is, this trick is really cool, and I'm sure a lot of you will be using it whenever you have a node with a country related stuff. You can see we have, okay, so this is Monaco, and we have the code for it, MC. We have Jordan over here, Lebanon, Serbia, Bulgaria, and so on. And like, yeah, this is cool. We like reddish, but wouldn't be even cooler if we would have a flag over here. Okay, yeah, that sounds good, but like we only have the code of the country. There is no link anywhere. And I'm sure a lot of you remember the image URL stuff. So we need to give the link to the image. And thanks to some guys on GitHub, let me show you. So what these guys did, and big kudos to Ashley, Hitchcock, and Jacob Sunol. So what they did is they actually created a GitHub repository of all the flags. Like, thanks, guys. So how can we use it? Let's go to see. Let's see the flags. Let's go flags. Let's go SVG. Okay, we have flags over here. Like a great, I mean, like a Croatian. I will pick a Croatian flag, of course. And we have a flag over here. Let's copy the image. So we have the link to this image. Let's go back to the lab. And if we add this over here and command enter, or you can click apply here, like, okay, what are we? Oh, we added to the entity. Okay, bad choice. So we don't want we don't want the companies, but we want countries.
Okay. We moved all of the companies to Croatia.
Yeah.
Which is wouldn't be a bad thing.
GDP goes burr. Yeah.
Considering that this is a data set of people evading taxes, so we wouldn't get any richer from having them. So.
Okay, so let's move to the countries. Okay, so we added, but yeah, okay, like cool. Every country has a Croatian flag.
And that I like more. This is what's happening. Yes.
Yeah, and you can see like the code is here, HR, and in each node we have the code for country. You can see here. Let's use that. Okay, how can we use that? I will now start the new image URL here. So you have a function that's called format, and you can format strings in there. You have few examples how you can run it. And by the way, let me just show you on the docs. If you don't know what GSS can provide you, just go to the Memgraph Lab graph style script and you have a reference guide. And you have all the functions. Let's go to the GSS functions. You have all the functions, examples, and what it will return and so on. So you can really see what GSS can give you in terms of visualizing your graph. Okay.
When in doubt,
yeah.
When in doubt, the docs you need to seek out. So everything is on the docs.
Nice one. Okay, let's copy this. Let's add the string here, and we want to change these two letters. Okay, let's change this. Okay, here. And I'm sure you already know we want to use the property function. Get from this node, okay, what's the name of the property? ICO2 code. Blah, easy. Oh, yeah, I have this image URL here. Let's see. Let's run it. By the way, you don't need to click this apply. You can just click Command Enter or Control Enter. Okay, where are the flags? Okay, so what's wrong? What's wrong? I'll help you out. So this is in uppercase. And as you can see in the links, let's go back to the actual links. all these flags are in the lowercase. Well, we got that covered as well. So there is a function called lowercase. Let's lowercase this.
GSS.
And let's click.
GSS needs some machine learning capabilities.
Yeah.
GSS needs some machine learning.
But yeah, here they refactoring.
And voila, like all the flags are in there. Like how cool is that? Like one-liner. And you can use this whenever you have a country in there. And I will show you one more trick. Now this is really just for you. And this builds GSS on a next level. I already told you we love developers. So like who wanna click and do styles? Let's code it. And what I wanna show you, like in this graph, like show me European countries. Yeah, you know how hard it will be, like where the European countries is. Like it would be cool if we can somehow make them really large so we can see where the European countries are. Let's do this. So how are we gonna do that? Let's click on any, let's find some, okay, some country. Oh yeah, we have Monaco here. You can see we have the region Europe. Awesome. We will definitely use that field. Let's do that. Let's see that region. Okay, so we will create a new node style. And what we want to do is we will say where property of my node region is equal to Europe. Okay, and let's make size 40. Enter. Wow. Okay, this works. So these are the European countries. Well, they are really too large. Let's make them at least half the size. Okay, like it's really easy to see where the European countries are in this dataset. We have France, we have Czechia, we have Russia, Netherlands, and so on. Okay, so that's cool, but let's get to even cooler stuff. For example, what we found is
sorry, you know what this reminds me of?
What?
The game, you know the game? Agar.io, AGAR.io.
Ah, yeah. The
all of
the or fish, yeah. Or
they eat smaller ones. So I feel like
True.
These ones will eat everything.
Yeah, but so what I want to show you is like, okay, so we have the countries, all cool. Let's just lower them a bit. They are maybe too large. Okay, 15 is fine. Okay, now we wanna like make nodes bigger of all the people from Europe, so connected to Europe in some way, connected to Europe countries. And you can see we don't have that information over here. Like we don't know, well, we have where the particular person is from, but we don't know if the person is actually connected to the European country. So how we can do that as well in the GSS. And this is something new that we added in this recent version of the lab. So let's get to it. So what we need a node style. And what are we going to do with it is we want to say, so you have this function adjacent nodes. And what it will do, it will return all the adjacent nodes to the actual node that you added. So what we want to do, we want to check if any of these adjacent nodes is actually Europe. So we can copy this. Okay, and we can say size, let's say 15. Oh, any function must be a function, not a Boolean. Oh, okay, yeah. So what it does, if you hover over the any, you can see that the first argument must be array, the second must be a function. Okay, and this is the actual error that I want to show you. So this must be a function that has argument I, and it will run I for every single item here. Let's apply, and now, can see all the nodes are in bigger size now, like all the nodes connected to the European countries. And what I wanted to show you is what developers do not like. They don't like to copy things. Like imagine if I want to change this to something else, I need to change that in several other places. And what I can do is I can say define. I can say I want to define is Europe, and I want to say it's a function that will receive a node, and the body of that function is this. Oh, and congrats, you just became a GSS programmer. And what does it mean? I can remove all of this and say is Europe of this node, and use this and change over here and say is Europe of all of this. And I think I have, well, we will see. Oh yeah, I need one more. And you can see the graph. Well, you can think, yeah, is that working? Let me show you that it is. Like you just define the function and you can use it throughout the style that you have. Why is this cool? Yeah, this is really cool because you can make your style really useful in few lines of code. You can actually style everything up. And whenever you have a really cool style like this, you can always save it. So Pandora Papers, Europe. Let's save it. Why we want to save it? Because if you get out of the query context and if you go back, we will always apply the default style. And now if you want to apply your one, go click apply. And that's it. You have the style that we just wrote before. So yeah, this is just to show you a bit about the new stuff that we added. The latest queries, I'm sure you're all aware of. You can see all the queries that you have been running on your lab. We already showed you query collections, so you can group your collections and then use them in any demo, or you don't need to write them in your other applications. And all the others, we gone through the streams. Import, export, currently we only support the Cypher format, but we plan to add CSV and JSON in the future. Logs, you already seen the logs, so these are the logs where you can see what's going on with our Memgraph. As you can see, we are losing connections from time to time, but no worries, it will reconnect. And last thing I want to show you is the actual query modules. Now, within the lab, you can create a remote modules to your Memgraph. So you can say, this is my module. And what we will do is we will actually load and show you an example function, an example procedure. So there are two different ways. You can read about them on the docs. I don't want to prolong this launch call. I want to just show you how you can use these. So let's save this. Oh, hello, name from Memgraph launch. Okay, so what we will receive a name, and then we will say hello from Memgraph launch, and this is a procedure that will receive some argument and return a record. And let's use this. Let's save it. Oh, so let's save and then close it. Cool. Let's add a vertical split so we can see the query module, and let's use it. So how you can use the hello function, you can always see an example over here. So let's say return my module.hello function and hello everyone. And if we run this, you can see the actual message from the procedure the function we just created. So hello everyone for Memgraph launch. Like, check this out, like officer, return my module, hello function, and dot name, and let's like limit 10. Hello Abdul, hello John Daly, and hello, like you can see how you can easily use these functions as well as the procedures. This is the hello procedure, and you have an example how to use this one. So we can say call and then my module dot, it's hello procedure. Oh yeah, now it has. So it needs an argument, let's say n.name. Let's yield all three, and let's return all three. So my input argument and my vertex count, and let's limit to 10. And let's run this. And now we have ran the Memgraph procedure, the custom one we actually created, where we are returning the input argument, which is name, and we are counting how many nodes are in there.
Nice.
Yeah, that's like you can see here that we are counting nodes in our graph database. And yeah, this is the new lab, new cloud, and this is the demo of, we started with the running Memgraph in browser, connecting the stream to the Amazon book recommendations, ratings actually. We created a recommendation. We started with PageRank, and then we finished up with the dynamic one, more suitable for streaming data. And we finished up with some new features from lab to show you what's new in there. And we are happy for you to check it out, try, use, and to improve your graph experience with Memgraph. Yeah, that's all. Back to you, Don.
I cannot hear you.
Sorry, I'm muted. Sorry. Thank you everyone for joining the stream and looking at this demo. Thank you, Toni, for giving us an amazing overview of what's new. I think you went through everything that someone could possibly want when building the app. So it's really like a complete example. Marko, go ahead.
One more interrupt. So I'm really disappointed because on a legit live demo, not a single failure. How come?
Yeah.
Not a single thing broke, unlike at live demos of some other graph companies that usually have them. So you can really test the resiliency of the whole Memgraph Lab, and Memgraph Cloud. But you will also see, given our mistake and the lack of preparedness, that we haven't actually prepared any of these things. So all of these things are live in the moment. So it is as easy as it is for us to kind of go through all of these. It's as easy for you to actually go and test it out. So now I will switch up my slide. See, I'm already mixing the cloud with everything that I'm doing. So I guess I'll be using the cloud a lot from now on. So that's it from us. Thank you so much for sticking it to the end. Thanks all of the community who helped us with all the recommendations and everything to get these features much better. And if you go to memgraph.com/cloud, you will get the free 2-week trial of Memgraph Cloud, so you can test all of these things out for yourself. Memgraph.com/lab will give you access to the lab. You can either get it through the cloud and then in the browser, but you can also go to memgraph.com/lab and you can download the desktop application so you can use it locally. And for all of the questions, we will be hanging out in our Discord community. So let us know if you have any questions, anything that we can help with, any feature improvements as well. And of course, check out our GitHub repository, github.com/memgraph. We have a bunch of repositories there. Our core platform Memgraph is there. We have the MAGE, GQLAlchemy. Give the code a peek, contribute if you feel like it, and you can start using it today. I think that's all that I had to mention. Now the YouTube stuff. Give us a like, share with your friends, subscribe to our YouTube channel. You need to smash the like button for the YouTube algorithm. Otherwise, the YouTube will not be recommending this awesome video to anyone. And we'll keep the video up after the live stream ends, so you can always go back and rewatch it, and you can share with anyone you think this information would be helpful. Thanks for watching. cloud.memgraph.com. Check it out. Thank you, Toni. Thank you, Marko, for helping us with this live stream. And I guess see you all on Discord.
Yeah, thank you. Thank you as always. Like, share, subscribe.
Thanks, everyone, and enjoy. Yeah.
Take care. Bye-bye.
Bye-bye.
We are signing out. I have to figure out how to stop this live stream.